Okay, the converse of Pythagorean theorem is basically using Pythagorean theorem to see if a triangle is a right triangle. So, remember, a squared plus b squared equals c squared. So, we're going to talk about if a squared plus b squared is more or less or equal to. So, here's what we do. We take the largest and we square it. And then we take the other two and we square them. We add these together and we compare. 161. So 100 is greater than 61. So it's not a right triangle because they're not equal. Only when those are equal is it a right triangle. But since the long side is squared, is way bigger than the other two sides squared, then we have an obtuse triangle. And I can kind of envision it in my head. Like if 5 and 6 are short, if 10 is long and 5 and 6 are short, they're going to end up being spread into an obtuse angle. If that makes sense. The next one is the longest side. Guess if I'm really good, I'll keep the same colors. Is 49. The other two sides are the same, right? So we have 25 and 36. And that adds up to 61. So 49 and 61, 49 is less. So think about this being acute is what it is, an acute triangle. If 7 is relatively short, then 5 and 6 are going to be closer together, which makes an acute angle. All right, biggest side, 25. Other two sides, 9 and 16. And 9 plus 16 is 25. So, I wrote it in the wrong color, but those are equal. So it is a right triangle. And if you remember from yesterday's notes, this is a triple. And we talked about the triples and that we always know that they make right triangles if you recognize them / memorize them. All right. 13. I would love it if you'd pause the video and try to do the next 3 by yourself, but whatevs. All right, 13 squared I know is 169. 8 squared is 64. 9 squared is 81. If I add those together, I get 5, and 6 and 8 is 14. So 169 is greater than 145, so it's an obtuse angle, or obtuse triangle. The 11 squared. I'm going to go ahead and write 13 squared, so I cannot keep changing colors on that one. Okay. 7 squared is 49. 10 squared is 100. So that's 149. 121 and 149. 129 is less. So it's an acute triangle. And I wonder if the last one's going to be a triple. Let's find out. 5 squared is 25. 12 squared is 144. That equals 169, which means that these two are equal, which means it's a right triangle. So, summing that up, for a right triangle, a squared plus b squared equals c squared. For an obtuse, a squared, now I'm writing it backwards from what we were just doing. So a squared plus b squared is less than c squared. And in an acute triangle, a squared plus b squared is greater than c squared. So I just basically took what we did above and flipped it around, because in our table we have c squared is greater than a squared plus b squared, which if I flip it around is a squared plus b squared is less than. So obtuse is a squared and b squared less than, which kind of seems like it's wrong because it seems like it should be greater than, but it's not. All right, so basically all we're going to do is tell if these are right triangles, or if it's even a triangle at all. Do you remember the rule for if it's a triangle at all? Let's put this in blue. Is it a triangle? And we did this. The two sides have to be longer, two shorter sides. Sum is greater than the long side. So 5 plus 7 is greater than 10. So it's a triangle. What kind of triangle? I have 5 squared plus 7 squared is 49, 59, 69, 74. 74 is less than 100, which is 10 squared. So obtuse. Okay. So the first thing we're doing is it a triangle? 5 plus 8 has to be greater than 17, and it is not, so it's not a triangle. So that's the first thing to do, because if it's not a triangle, don't even bother with the rest. Okay, I know this one's a triangle because I can tell that 3.8 plus 4.1 is greater than 5.2. All right. And now you're going to go, ooh, I wish I had a calculator. I don't want to say me too. All right. So 3.8 squared is 14.44 plus 4.1 squared is 16.81, and that equals 31.25, and that is 5.2 squared is, so that is greater than 27.04. So if 31 is greater, a squared plus b squared is greater than it is acute. Okay, I'm gonna change colors just to separate stuff. All right, triangle. Well, 9 plus 11 is greater than 15, so yes. 9 squared plus 11 squared (202), 15 squared is 225. So 202 is less than 225. So that means it is obtuse. Okay. This one's a little bit going to make your head hurt, but maybe not. I do know that 7 times the square root of 6 plus 11 is going to be more than 13, greater than. Because I have 11 and 7, and it's actually more than 7. So that's more than 13. So let's figure out squaring. So remember that we did this before. 7 square root 6 squared is 49 times 6. Which is 294. Okay, so we have 121 plus 294 equals 415. And 415, I know, wow. Oh, you know what? Just for fun. Okay, let's do this because I did this all wrong. Okay. Let's think about this because here's what I need to know. 7 times the square root of 6 is about 17.15. Oops, that's a bad one, isn't it? Okay, so this is the longest side. So that means that to see if it's a triangle, I would have to say 11 plus 13 is greater than 17.15, which it is. But that means that I'm adding together 11 squared plus 13 squared. And that's going to be 290. Okay, and I'm comparing that to 294. So 290 is less than 294. And that is obtuse. So how did I know that I set it up wrong? If you're interested. When I got 294, so let's take this 294 over here. When I said 294, I was putting it and comparing it to, because that's a squared, that's what I thought was a squared plus b squared. And I know c, I thought was 13, so I was comparing it to 169. That's really hugely a lot different. Which doesn't mean it's not, but I just thought, okay, that's weird and that doesn't look like one of the problems we've worked. So that's when I realized that I needed to check and see how long 7 times the square root of 6 was. So then I went and did this and said, oh, if that's 17.15, that's the long side. So that's C. So then I had to go back through and do A was 11, B was 13, and C was 7 times the square root of 6. And yes, I just put 7 times the square root of 6 in the calculator to find out that it was the longest side. So it is obtuse, but 7 times the square root of 6 is the longest side. So good to know that if you're doing some work and you go, wow, those are really weird, long, big numbers compared to the other numbers we've tried, I might want to go back and verify that I'm using the right triangle sides for A, B, and C. A and B don't matter. They're switched around. They're, what's that called? Interchangeable. But the longest one is the longest one, and I did not use the right one, the correct side for the longest one. So